Here's a fun one. It's we have to find weight W. And if you don't see this, I'll draw a free body diagram right here on the picture. We're gonna have a tension in cable AD, AC, and AB. Those are our tensions in the three cables, but not just that. All right, where's the tension coming from? What's the force? Well, the force is right here, coming down. And what that is, it's the force of the weight of the, I don't know, I'll call this a coffin. Let's make this morbid. This right here is a coffin being lowered into its grave. Uh, so, um, yeah, that's the free body diagram. Simple as that. So from here, we start out by step 0, right? Step 0 is draw your free body diagram, or at least list the forces on the picture, right? I think some teachers allow that. I think that's fine. It saves a little bit of time. You're going to see by the end of the problem that it doesn't even matter. There's so much time. This pick takes so long. Maybe every second matters, but it's almost to the point where it seems like you might as well just recreate the Mona Lisa on the side with how long the problem takes anyway. So we're gonna have points A, B, C, and D. O is the origin. That's not really a point. So those are all of our points. And remember that this is going to be X, Y, and I'll put Z maybe a little bit later. X, Y, and Z. So for X, for this one, we're going to have 0X, negative 45Y, and 0Z. So there's the first one. And the second one, B, it's going to be 28X, 0Y, and 0Z. Point C, it looks like it's going to be 0x, 0y, and it's going to be negative 28, or not 28, negative 24 z. And point D is going to be negative 26x. It's going to be 0y, and it's going to be 18z. So knowing these now, we have defined vector AD, vector AC, and vector AB. So this is going to be finally step 1 is listing the points. Step 2 is finding the vectors, which is, it's kind of just like grouping 2 points. So instead of just having a dot here and a dot here, we're just connecting the two, and we're saying this is now a line segment. Or I guess maybe a line. I don't know what the segment adds to that. Maybe there's people just say line segment to say one more thing. That's what people want in life, is just to say one more extra detail. Maybe it's super important though. What's the difference between a line and a line segment? I guess a segment would be this is why I just called it a line afterwards. Like a segment's like part of a whole, but I'm just saying that's the whole entire line, yo. That's it. So maybe that's the big difference. I'm gonna start with AD at the top just because, and then I'm gonna do AB and AC. And I say just because, but it's really because we're given cable AD is equal to this, so AD is of a little bit more importance. So vector AD, we're also gonna have AB and then AC. And how do you do these, right? So you take the second one and you subtract the first one. So if I were doing AD, right? What this really would be is negative 26 subtract 0, right? And this would be 0 subtract 45, which means that this would actually be a positive 45. And this would be 18 minus 0, so this would be 18. And same thing with AB. 28 minus 0, left with 28. And this would be 0 subtract 45. 0 subtract, that's going to be 0. And AC, 0, be 45. And then that's going to be negative 24. Now, not only do we need to find the vector, but we need to also find the magnitude of each of these. So let's do the, I don't know where we can do this. Yeah, okay. I guess we'll do it right here. We're going to have magnitude AD, magnitude AB, and then magnitude AC. So what this is going to be, it's going to be the square root of I hat, J hat, and K hat for each of these. And it's not just going to be the square root, it's going to be the square root of everything squared. So here, we're going to have a negative 26 squared plus a 45 squared plus an 18 squared. Here we're going to have a 28 squared plus a 45 squared plus 0 squared, and here we're going to have 0 squared plus 45 squared plus a negative 24 squared. I'm getting a 55, and then square root of 28 squared plus 45 squared. Gosh, hold on. Plus 45 squared, and multiplied it. I'm getting a 53, and then a 40 square root of 45 squared plus 24 squared. I'm getting a 51. This is the magnitude of each of these vectors. I would call this maybe step 2. And I would lump, whoops, 50. I would lump this also into step 2. Now step 3, right, is to find the tension. Now, how do you find the tension in all of these vectors? Well, we've got the, oh no, before that, sorry, I'm getting a little bit ahead. We need to find the lambda AB, lambda AC, lambda AD. This is finally step 3. Now let's find lambda AD, lambda AB, and then lambda AC. And then all of this is your vector, right? Right here, this vector, subtracted by the divided by the magnitude. So here, we will have an I hat, a J hat, and a K hat for all of these. So this is going to be a negative 26, 45 and an 18. It looks like those two are plus. This is going to be a 28 plus a 45 plus 0. And this is going to be 0 plus a 45 minus 24. And this whole one here is going to be 55s. This AB is all going to be 53s. And AC is going to be all 51s. Okay, now we have step 3. Step 4 is tension, right? Now, since we're running out of room very quickly here, I will show you the magic trick on how to quickly get your tension vector. Now, what it is tension, right? The tension in say AD is equal to lambda AD TAD, right? So what you do, save maybe some space in this case, or maybe some time on the test. Although I don't suggest skipping any steps or trying to shortcut, really. I don't suggest shortcutting it, even though it might be the most practical thing to do. It's statics, and you don't have that much time on tests. So it might be the right thing. What you do is you just write, since we know TAD, 948. Since we don't know TAB, and then TAC. And what these turn into is, instead of lambda TAD, these turn into tension in all three. So step 3 is now step 4. Pretend we just redrew everything. All right, look at us go. From here, we've got sum of forces. All right, we are going to have the sum of the forces in X, sum of the forces in Y, and sum of the forces in Z. All right, what are the forces in the X direction? Now remember, this is X, Y, and Z. So in X, we have all of these straight down. In Z, in fact, to make this even clearer, all the zeros, I will just put a big 0 so I don't confuse myself. I'm very good at confusing myself. So in X, we're going to have a negative 26 over 55 TAD. Now we know TAD, so we can immediately say that this is times 948. Now it's going to be plus 28 over 53 TAB. And then, of course, plus 0 TAC. Okay? So immediately we can solve for TAD with this. Sum of the forces in the Y direction. This is going to be 45 over 55 times 948 plus 45 over 53 TAB plus 45 over 51 TAC. And right here in the Z, it's going to be 18 over 55 times 948 plus 0 TAB minus 24 over 51 TAC. Now we can do two things. We can immediately here get TAB, and we can immediately here get TAC, meaning we've got, forgot one thing right here, minus W. right? This is what we're trying to solve here. Forgot some of the forces are not just our cables that we just spent all this time solving for or searching for. It is also our W. We can do it that way, right? That's the easy way. I don't like that. That's not how I rock and roll. No, no. Instead, what I could do is I could set up a 3x3 matrix. So let's do that. And what this matrix is going to look like is we're going to have right here. Okay? We're going to do our TAB, our TAC, and our W. Those are our unknowns, or at least the coefficients of all these. And then we're going to inversely multiply this by everything we have solved for in the X, which in this case is this here for the Y, and then this here for Z. So in here we're going to put TAD, right? And of course this is going to be X, Y, and Z for all of those. And that's going to equal our TAB, TAC, and the last one is going to be our W. That's what we're looking for, is our W. Our W here is going to be 0, -1, and 0. Our TAC is going to be 0, 45 over 51, -24 over 51. And TAB is going to be 28. Let me try that a little better. 28 over 53. 45 over 53. And 0. And then here, this is going to be -26 over 55 times 948. It's going to be times 948. It's going to be times 948. And the coefficient here is going to be 45 over 55. And then here is going to be 18 over 55. Okay. Now we can plug those into the calculator. Okay, we got one matrix done, and this one's going to be -26, 55 times 948. Be 45, 5 times 948. Be 5 times 948. All right. That should be an 18, right? Yeah, okay. Matrix A to the inverse of matrix B. And the weight that I'm getting Dang, hold on. I'm actually getting the correct TAB and TAC, but not the correct W. What the heck? Oh, I know why. So, my W is equaling 914.14. Now this is let's see, that's just mass, I believe. So what if we do 914 times 9.8? No. What the heck? Why is W wrong? Hold on, hold on. I'll check my matrix. The other ones are all right. I swear. 0, -1, 0. Yeah, man. That's that's bizarre to me. Okay, with this though, I'm getting TAB is 848, which is right. TAC is 659, which is also correct. But my W, something didn't seem right to me about that. I'm gonna see if that math added up. 1855. Yeah, that does look right. Well, let's plug it into the sum of the forces in the y, because this is a little bit weird to me. So W is going to be equal to all of this, and knowing that we just got TAB and TAC is what they are, let's do 45 or 55 times 948 plus 45 over 53 times TAB, which we just got as a negative. Which it shouldn't be that either. So I think something in my matrix was a little bit wrong, but not wrong enough to give me wrong answers. It's a little bit odd, but so let's just play 848.275 plus 45 or 51 PAC, which I'm getting is 659.29. Okay, yeah, no, that gives me the correct W now. So W equals 2077.59. That's W. And I'm going to look over my matrices. I did them a little bit quick, so I'm going to make sure I don't have any 28 over 53, 45 over 53, 0, 0 and 0, 45, 51, and then that should be negative 24, 51. Okay, actually, does that change everything? Okay, I got it. This I didn't have negative in my calculations. Okay, I'm getting it all correct now. 845, 659, and 2077 through the matrix method. Okay, I got it. Wowzer. Okay. There you go. That is how you find W.